Hi everyone. I have a midweek 4 update for you because I haven't talked about what you're going to be doing this week. Now that the midterm is over, if it makes you feel any better, you're past the midway point, right? So you're closer to the end than you were to the beginning. That's a good thing. Um, I'm in the living room. At some point, you'll probably hear some puppies barking, although you probably see one this way, kind of sleeping. No, she's sleeping. The other one, you only gotta have the butt. That's the rest of her. And I have two that way. They are full of pizza, so they should be pretty quiet. Midterm. Midterms are graded. They are in my Labs Plus. I had one student give me no name. You're a question mark right now. So if you go into my Labs Plus and you don't have a grade in your midterm, it is just blank, please let me know and I will put your grade in. And if you don't go into my Labs Plus to check your midterm because you don't have my Labs Plus, please do that very soon, as we are at the end of week 4 and there are only 8 weeks in the semester. There was a curve for one question, and so that adds 4 points to everybody. I did have 100, yay! So you got now 104, so that's very exciting. I'll talk about that question and post the key right after. I had one person that had a conflict that we knew about very early on in the semester that needs to take it, but as soon as that happens, I will post the key for you. I'm guessing probably early next week. I know you're probably like freaking out wanting to see, but hang in there a little bit longer. Worry about Chapter 7. Speaking of Chapter 7, let's go over that because that is all about probability. Now, I have Moodle up here, you see, and I have, if this will cooperate, whoa, that was a little fast. I have an additional PowerPoint so you can kind of scroll through the whole thing. I think it's probably from my stats class. It's been a while since I've looked at that one. And then there's one for each section. I would suggest, if you haven't started doing this, going through the PowerPoints before you jump into the homework. Even if you don't study every single slide, you want to kind of go through this. It will make your life a lot easier, especially for the labs, because I don't use just the blanket textbook PowerPoints. Like, I take them and I fix them and I put in more stuff, so that way when you do go into the homework, because I know what you're going to expect, I know what's in there because we picked those questions, and I know what kind of labs I'm going to ask you to do, you can kind of see where we're going. I also have a bunch of other videos. Some of them I make, some of them I steal. Again, if there's anything that is not there that you need to be there, let me know, and I will make that happen for you. Just want to do a very short introduction to probability, and then I'm going to bring up the lab so that you can see the lab, because there's this one mistake that everybody always makes on the lab. And if you watch the video, you won't make that mistake. So I'll know who watched it and who didn't, right? I use cards a lot, and I use cards on the lab, as you can see. Now, a lot of people don't know what a deck of cards look like, so you can go to Google, just type in deck of cards, and you will have a large selection of pictures to look at. We'll go to images, and yeah, this is the one I usually wind up grabbing because it's kind of got everybody nicey-nicey. And actually, while I do that, I am going to give this guy a little bit of a snip and bring it over so I can write. I'm going to have to make it smaller. I don't know why it does that. It makes it so big. All right, I'm going to squish it up a little bit. All right, so a deck of cards, there's 52 cards. There are 4 suits. There's 13 cards in each suit. It goes from ace up to king. A lot of times we say ace is the highest card. That's usually what we talk about, but it's kind of easier to talk about it when I'm explaining it at this end because it looks like a 1. Goes up to the 10, and then it's jack, queen, king. These guys with the heads, right? These are your face cards. The textbook calls them picture cards. Nobody calls them picture cards. That's ridiculous. It's a face card. Ace is not a face. In order to have a face, you got to have eyeballs. There's no eyeballs over here on the aces or these numbers, right? So these guys all have heads, so they have faces. No heads, no face. So these guys are face cards. So there's 12 face cards altogether. Let's talk about probability rules. So there's simple probability, where it's like you flip over one card or you flip one coin and one thing happens. You can also talk about combined probability, like I want this or that, or I want this and that at the same time. Or you can say I want this and then I want that. So you're kind of doing two things, like do something, see what happens, do the next step. So like a two-step process. Here's the other thing. You can also have two different types of probabilities that you can calculate. And you'll do this in your lab. There's experimental probability. Math people are not creative, and so experimental probability is that you actually do the experiment. And then you just count up what happened. So if I want to flip cards like you do in the lab, and I flip over 10 cards and I say, what was the probability of getting a king? And you got 3 kings somehow when you flipped over 10 cards, then the experimental probability of flipping over a king would be 3 over 10. So you would actually do the activity. More than likely, though, when you're doing problems, you're talking about what's called a theoretical probability. So if I were going to do something, what could happen? And so I'm going to talk about theoretical now, and I'll talk a little bit more about experimental when I pull up the lab. So if I said, what is the probability with a capital P that I flip over one card and it is an ace? I would say, well, I'm going to start from the bottom and head up. My denominator is what we call sample space, and that's all the things that could happen. Like if you didn't care, it's just like how much stuff is out there to be had. And well, there's 52 cards in the deck, so my sample space for flipping over one card is 52 because there's 52 cards in the deck. And well, up top is the favorable outcomes. What is it that I want to happen? And that is I want to get an ace. That's what's in here. And so there's 4 aces. So that would be 4 out of 52, which you can reduce to 1 over 13, or you can make a decimal. Let's see what that is. 1 divided by 50. No. 1 divided by 13. 0.0769. They do usually go 4 decimal places, but if it winds up being 3, that's fine. Now, cards have a lot of the same probabilities that pop up because it's very symmetric, right? So every suit has 13 cards. They have 1 of each denomination, right? Half the deck is red, half the deck is black. There's 4 of each type of card. So like there's 4 aces, there's 4 twos, there's 4 kings. So if I wanted to know what's the probability of flipping over a 10, well, there's still 52 cards in the deck, and well, there's 4 10s because these are 2 independent events. Like I'm going to look at and be like, all right, cool, and then put back in. Now I'll flip again. So you get this again, and that's okay. Now, what if you were playing cards and you needed an ace or a 10? So if you go into your pile of 52, either one of them would work out. And so, well, let's talk about the ace, right? We know the probability of flipping over an ace. Well, that's 4 out of 52. And what's the probability of flipping over a 10? Well, also 4 out of 52. But either one of those would be fine. And so when you see or, you're going to add those 2 probabilities. And so this is going to be 8. Now, when you add fractions, you don't add denominators. It's 8 out of 52. Right? One event. There's these 4 that are good news and these 4 are good. So there's 8 things that are good out of the 52 in there. And so that's 2 out of 13. About like 15 or 16, right? 0.15, 0.16, whatever that is when you multiply by 2. But here's the thing with ORs, and I'm going to get rid of this over here. You got to be careful for what I call double voters. What if I wanted a heart? Yeah, a heart or not a queen. How about, let's stick with ace, a heart or an ace. All right, well, when I go into my big pile here of stuff, I know I got 52. How many hearts are there? Well, here's your hearts. There's 13 of each suit, so there's 13 hearts. I don't care which one, it's just got to be a heart. Or means add, all of these queens. These are good. No, I didn't pick queens. I picked aces. All these aces are good, so all of those are good. All right, and now all of these are good, because all of these are hearts. So there's 4 aces, we know that. But look what happened when I circled. I circled all the aces. I'm going to do a highlighter so that you can see it, right? So here's all my aces. Here's all my hearts. That ace of hearts, when I said, hey, who's an ace? It raised its hand. When I said, hey, who's a heart? It raised its hand again. So if I add these up, it looks like I have 17, but I don't have 17 cards in the deck that are good. I got 4. I already counted him. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This double voter, however many had an overlap, which is usually 1 or 2, right? Just with cards, it'll be 1. You have to take that out because I had 1 that I counted twice. So I call him a double voter. He raised his hand twice. So it's not 17 over 52, it's 16 over 52. And I promise you, I will ask you that on your final. Right? That's like a classic. I always ask that. What if I wanted a heart and an ace? So I flip over 1 card and I want both of those things to happen at the same time. There's a couple of different ways that you could do this. The easiest way is to think about the ors. Well, how many cards are both an ace and a heart at the same time? The double voter. Now, there may not always be a double voter, like with the ace or the 10. You can't be an ace and a 10 at the same time. You can be an ace or a 10. You can't be a spade and a heart at the same time. Can't happen. You're a heart or a spade. But you can be a spade and a 5 at the same time, right? So you want to look for how many are those. Where's the overlap? Where's the overlap? So these are called single events. So it's like you flip over 1 card and that's what happens. There's no card games where you play with 1 card. I don't think. So a pretty popular game, even though it's not only a 2-card thing, is a Texas Hold'em. And you get 2 whole cards. And then those you play, like those are unique for just you. And then there's 5 on the board, and you got to make the best hand out of the 7, the 2 you see and 5 that everybody sees, out of 5. Sorry, you got 5 cards altogether, and you can play all 5 on the board, but that's another story. The kind of crown jewel, right, when you play in Texas Hold'em that everybody gets real happy about, if you get dealt 2 aces, pocket aces. So I get dealt an ace, and then I get another ace. This means such that, and we kind of read this backwards actually. It means I get an ace given that I already got an ace. So it's actually that this is second and this is first. But the formula is pretty forgiving because we're going to do some multiplication, and multiplication is commutative, meaning it's the same both directions, right? 2 times 3 is the same as 3 times 2. So the formula is pretty nice. If you accidentally flip it, you're usually all right. So I'm going to go this way. Well, what's the probability of flipping over an ace on my first card? Well, we know that's 4 out of 52. But and then, and if you say and then, that's multiply, not and then. So and then another, right? So another thing. You multiply. But here's the thing. Let's say I get an ace. This guy's already got something on it, so let's pretend I get this ace. I can't get that ace again. That's not how cards work, right? I got dealt the ace of spades. That's out of the deck. So when I go to flip over a second card, there's not 52 cards in there anymore. There's 51 because that card's already out. And there's not 4 aces anymore. I already got 1. There's only 3 aces in the deck left to be had. So that's 3 out of 51 for the next round, right? Because I took this card out. You'll multiply these, and only because I do this all, well, I don't want to say all day long, but I do this a lot. I know that's 26 over 52, and that reduces to 1 over 221. What if you wanted 2 different cards? You don't want an ace and an ace. You want an ace given that, or such that you already got a king. All right, well, here's my kings. Let me unscribble that. What's the probability if I flip over a card and I get a king? Well, all the cards are out there. There's 52 of them. There's 4 kings. There's 4 of each type. Let's say I get the king of hearts. So I get him. That's not in the deck anymore. So now when I go flip over another card, it's not out of 52. It's out of 51. But this time, I want an ace next. I don't want another king. All my aces, they're all still there. It's not 3 out of 51. All 4 aces are still in there. So that's still 4 out of 51. So it does help if you're not really familiar with what a deck of cards looks like, which is not really uncommon, that people don't really play a lot of cards, I guess, to pull this up, and it will help you so that you can visualize what's going on. On the midterm, no, the final, if I forget to give you a deck of cards, tell me, and I will put it up on the projector so that you can kind of see what's going on. Let's multiply these two things, so I get 16 over 2652, and then I can reduce that. Now, if you don't know how to reduce in your calculator, you might want to watch this. This is nice. So I got 16 over 2652. Actually, let me do this. I'm going to say 4 out of 52 times 4 over 51, and I get that, right? But maybe the answer they wanted as a fraction. Hit math, enter, enter, and it reduces it for you. So now let's say you did it by hand and you're like, oh, I got to reduce this and I forgot. 16 over 2652, whoops, 2. When you hit it, you get the crazy decimal. Then you can hit math, enter, enter, and it will give you the reduced form. It's probably one of the nicest things that the calculator does for you. Now, let's say you wanted to do this, but you do something that's called with replacement. I'm going to go back to the ace and an ace. If I say with replacement, that means you're going to take out that first ace and be like, all right, cool. That was 4 out of 52. I got my ace. But then when you're going to look at it, you're going to be like, all right, I got that. And you're going to put it back in so it doesn't get scribbled out. So when you go back in to pull out another card, there is 52 in there. And there still is all 4. This is not really common. We talk a lot more about doing things with replacement in a statistics course, not so much in like a probability gaming type of thing, right? Because you don't get to have the same card twice in one deal. But there's a couple that are like that. Like you take it out, you look at it, you go, all right, and then you put it back in. But the storyline keeps going. You're going to want to go through the PowerPoint. You'll have a lot more examples. Let's transition to the lab. The lab is not as long as it looks, and it's right here, and you can see underneath I put the random card flipper. I really like the random card flipper. Even if you have a deck of cards, you're probably going to want to do this, and it's set up ready to go, because it pretends to shuffle for you, because you're flipping one card, and you're like, you're going to write that down, but it's not, because you have to do a lot of them. You can't just keep it out and then keep going. You have to look at it, write it down, put it in, shuffle, shuffle, do it again. So this does the shuffle for you, and you could just keep hitting again, and it puts the same cards back in. I don't know why I keep getting so many hearts. There we go. Mix it up a little bit. So the first thing you're going to do on the lab is that you're going to find the theoretical probabilities, and we've done some of this already. But then you're going to do 3 experimental probabilities. On the first one, you're going to use the card flipper, and then you're going to flip over 10 cards. So let's see, I'm just going to make some up because I forget, but I know I had a king of hearts, so that's a king, and I'm going to put H for heart, and I know I also had a king of spade. I had like a 5 of clubs. I'm just going to make up some stuff. 7 of diamonds. I'll say jack of diamonds. No more. How about 3 of hearts? I'll do 1 queen of, let's say, clubs. And I'll do 1 more queen of diamonds. All right. Now you're going to find the experimental probability. I did this 10 times. So my sample space is not 52. I don't have 52 things in my table 1. I have 10. So my denominator is out of 10. How many hearts did I allegedly have, right? I have 1, 2, 3. So that would be 3 out of 10. And I said for all of these to go ahead and write them as a decimal to 3 decimal places. It's just a lot easier to compare decimals and fractions. How many face cards do I have? 1, 2, 3, 4, 5. Ooh, a lot. Okay. How many are a heart and a face at the same time? So I'm specifically talking about jacks of hearts, queen of hearts, jack of hearts, queen of hearts, king of hearts. I got only one, right? Only one king of hearts. And I got other face cards, but only one that's a face and a heart. Only one face that has a heart. It's a rough crowd. There we go. Now, or I can be a jack, queen, king, or a heart. Now, if I'm at them at the same time, I don't count them twice. So this king of hearts is still only going to get counted once. So 1, 2, 3, 4, 5, 6, 7. Now notice, if you count up the hearts, let's see if I can do this. 1, 2, 3. And then you count up the faces. I got 1, 2, 3, 4, 5. Well, 3 plus 5 is 8. But one of them is a double, so you'd have to subtract it. So experimentals are a little bit easier to kind of keep track of because you have them all on the table to count up what you have. Now, that's the first part. And you're going to compare those little decimals that you have here. That should be a 0.3 down to 0.03. To what you get for these theoreticals up here. And we kind of talked a little bit about some of these. You can probably see some of the same numbers. Are they the same? Are they different? Sometimes I get people that are like, oh, it's almost exactly the same. Sometimes it's way off. It depends. Now what you're going to do is you're going to do that experiment like you did with the 10, 16 more times. And then you're going to copy like this. I'm going to highlight the table, Control C, scoot down here, and I'm going to say Control V, and that, ooh, I don't want to do, well, I got some extra rows that popped up, but that's okay. I can get rid of them like this if I want to. If that happens to you, it's okay, just leave it. So then you're going to calculate the experimental probabilities again, include all 26, so this next rounds out at 26. Then what you're going to do is you're going to take your table 2 and your table 3, you're going to put it into a table 4A, and you're going to post that in that help form, and then you're going to take somebody else's 4A and put it in for 4B, so now you got 52 flips. Or you could pretend to do that and flip the card 52 times, but you probably don't want to do that. It's a little bit of a pain. And we've had some very nice people working ahead, and so I'm going to put them on the spot and pull up the help forum. And you can see some stuff here. Let's pick on little Molly. And you see she has her stuff there. So you could take hers and then you could like maybe post a reply to Molly, or you could just post yours earlier, by doing the add a discussion. And then you're going to do this with all 52. So now this is an experimental probability, but it's out of 52. Does that out of 52 match the 52 from the theoretical? It's probably going to be a lot closer. What do you think would happen if you did this 1,000,000 times, 1,000 times, right? You just keep flipping cards, flip your cards' life away, right? That is a very specific law, and you probably are going to see that in probably 7A, but I'm sure it makes an appearance in 7C as well, which is about the gambler's fallacy. Then you're going to save this lovely thing, and you are going to go into Moodle, and you're just going to use the link like you've been doing. And I'll get that graded for you. They are not fun to grade, but honestly, if you do it, it's pretty hard to not get at least half credit. I mean, you're flipping cards. So get that in, and then we'll worry about statistical reasoning next week. Hope you have a good week.